Hey everyone, Dr. Walker here. This is the guided examples video for video 227, which is called Working Backwards with Capacitor Circuits. There are several steps to solving these types of problems, but I prefer to show you by example, and then we can come back to these steps as a reference afterwards. So let's take a look at the example. This is the same example that we saw previously, and I have written down a few equations that will be helpful to us. So I wrote down the equation for capacitance, and I manipulated to solve for each variable one at a time. And I also reminded us of the equations for parallel and series capacitor circuits. When capacitors are connected in parallel, the voltage on each one is the same as the voltage on the equivalent capacitor. When capacitors are connected in series, the charge on each one is the same as the charge on the equivalent capacitor. Okay, so let's look at this problem now. It says how much energy is stored in the 4 microfarad capacitor. 4 microfarad capacitor is C3, so we're looking for E3. I'll call it E3, the energy stored in capacitor 3. We just talked about a similar thing in the video associated with this example. For looking for the energy in C3, we're not allowed to just do 1/2 CV squared and use the 4 and the 12 volts, because the 12 volts doesn't apply directly to C3. C3 is not getting the full 12 volts. So this is an instance where we have to simplify to one capacitor, which we did in the previous video, video 226, so I pasted it in here. Once we have found the equivalent capacitance, then we work backwards until we find what we need. So how do we do this? Okay, so we're going to start by looking at this last capacitor here. What do we know about this last capacitor? We want to know the capacitance, which we do. We want to know the charge and the voltage. We always want to know these three quantities. So C123 is connected directly to the 12-volt battery, so we know the voltage on C123 is 12 volts. We can write it down just for kicks here. V1234 is 12 volts. Okay, what about the charge on this equivalent capacitor? Well, we have the capacitance, we have the voltage, we can find a charge. The charge is C times delta V. So Q1234 is equal to C1234 times delta V1234. I find it really useful to write this underneath that same circuit because the values that we need to plug in are right here, right above. We don't have to go look for them everywhere. We're going to multiply 3.33 microfarads times 12 volts. In the calculator, I just put 3.33 times 12. I don't plug into micro. I know that the final answer will have the micro. That's going to give us 40 microcoulombs. Okay. So we found out everything we could about this equivalent capacitor. Now we're ready to work backwards. Which capacitor do we care about? We're looking for some information about C3. So we care about the capacitor that's going to lead us back to C3. Do you think that's going to be C4 or C123? Which one is related to C3? Well, the capacitor that has 3 in its name, C123, is related to C3 because C123 was a combination of C12 and C3. So we care about C123. Okay, so let's look at this capacitor. What do we know about this capacitor? Once again, we want to know the three quantities. We want to know C, Q, and V. We already know C123 is 10 microfarads. You see how it's nice to have it right here under the circuit. And then we have to think, okay, well, do we know the charge on this capacitor or do we know the voltage? So take a moment and think about it. Which one do we already know without having to do any computations? So this is where what I wrote here helps us. When capacitors are connected in series, right, these two were connected in series to yield this one. When capacitors are connected in series, then we know that the charge on the individual capacitors is equal to the charge on the equivalent capacitor. So without doing any calculation, we can bring back the charge. We can say, okay, we know the charge on C123, so we'll call it Q123. The charge on C123 is the same as the charge on 1234, so it's 40 microcoulombs. So because these two were in series to get to the equivalent, we brought back the charge. We can write series here if you want to, whatever helps you sleep at night, whatever you prefer to do. Okay, now that we know the charge on C123, then we're going to calculate the unknown quantity left, which is the voltage. So the voltage 123 is going to be the charge divided by the capacitance. And always use the numbers that you have right above you. The charge and the capacitance are right here. So you're going to do Q123 over C123. So that's going to be 40 microfarads over 10 microfarads. Sorry, this is supposed to be coulombs, not farads. 40 microcoulombs over 10 microfarads, and that's going to give us 4 volts. So delta V 123 is equal to 4 volts. Do you see what's next? What do you think is the next step? The next step is to go back one and figure out what we can. We care about C3. What do we know about C3? We already know its capacitance is 4 microfarads. We need to know either the voltage or the charge. Well, C12 and C3 were both connected in parallel to get to the C123. Right, to get to this circuit here, they were connected in parallel. When capacitors are connected in parallel, the voltage on each capacitor is the same as the voltage on the equivalent capacitor. So the voltage on C3 is the same as the voltage on C123, because they were connected in parallel to yield C123. So what we do is, instead of bringing back the charge, we bring back the voltage. And we say, okay, the voltage on number 3 is 4 volts because they were in parallel. And we know the capacitance is 4 microfarads. Now, we could find a charge, but we don't need a charge because the problem is asking us for energy. The equations for energy all rely on 2 out of these 3 variables. So if we have 2 variables, which we do, we have delta V, and we have capacitance that was given, then we can just find the equation for energy stored that has both of these variables, and that's going to be, the energy is 1/2 C delta V squared. And so we plug in the values that we have just above. We're going to plug in the 4 microfarads and the 4 volts squared. Again, don't put a micro in a calculator. Your answer will just have micro as part of the unit. And this will give us 32 microjoules. So that's the final answer. Hopefully you had enough room on your paper, it didn't get too crowded. But this is the idea of working backwards. Let's take just a minute to look at the steps that I wrote out to see how they can actually help us. Let's say you forget how you're supposed to solve this type of problem. Let's look at the steps. We found the equivalent capacitance. Calculate Q for C equivalent. That's the first thing that we did here. We found the 40 microcoulombs. Determine which capacitor will lead you back to the one in question. That's what we did. We found C123. Was this capacitor connected in series or parallel? Remember, C123 was connected in series to yield C equivalent. So that's what I wrote here. if this capacitor was connected in series, then now we know the charge on this capacitor. Now we can calculate the voltage. So that's what we did. Oops, I went the wrong way there. We said it was connected in series, we know the charge, and we calculated the voltage. And then we repeat. Go back to the previous step and repeat. The previous capacitors were connected in parallel, so we said we knew the voltage, we had to calculate Q. The previous step for C3, we knew the voltage. We would have to calculate Q if we had to keep going back, but we didn't have to keep going back. So we could just use the voltage and the capacitance to find our energy. These types of problems, hold on, let me just show my full face here. These types of problems, they do require a lot of practice. So I have a lot of practice provided. Definitely try them on your own, at least 2 or 3 problems, because it's a lot easier to look at me solve it than to solve it yourself. So hopefully after you practice it a few times, you'll feel confident with it, and hopefully you'll actually enjoy this type of problem. I'll see you in the next chapter. This was it for chapter 19.